Hello and welcome to another video. This time we're going to be looking at the DS3231 module. This is an i2c real-time clock module with a battery backup. This means that it can maintain the actual time even when your Agon is switched off. Looking at the module, we can see the usual i2c pins. There are also 3 solder pads to adjust the bus ID. And on the other side of the module is the battery. This keeps the clock accurate even when the Agon is switched off. In this video we're going to be looking at 3 different bits of software, although we'll only be looking at the first one's code in detail. The last 2 we won't go through the code, but all the code has been provided in the GitHub, so you can go through it yourself. So the first code we're going to look at is a simple demonstration of how we read data from the module. And in this example, we're simply going to print a basic clock to the screen with the day, date, and the time. If we run the code, you can see what we're going to be displaying on the screen. We have the time on the left. We have the day of the week. And we have the date, the 25th of October 2024. Obviously I've put these in UK format, but if you want to switch them round to US format, that's entirely up to you. The code to read data from this module is pretty simple. There's no configuration or things like that to deal with. We simply ask it for some data. So in the first section of the code, we're going to print the basic information to the screen, hide the cursor, and open the i2c port as we've done in the past. We'll then keep going around a simple loop waiting for somebody to press the escape key. We'll have a little delay each time we go around, but the main routine we're going to call is this update clock routine. So the update clock routine does 2 things. Firstly, it gets the latest data from the module, and secondly, it then prints it to the screen. So in order to get data from the module, first we have to tell it that we want to read from a particular memory register, and that's register 0. So we send 1 byte of 0 and write that out. We give the module a moment to realise what's happened, and then we read some bytes in. In this case, we're going to be reading 7 bytes of data from the module. If we look at the memory map of the DS3231, we can see why we're reading 7 bytes. With the address down the left-hand side, we're starting at 0 and going to byte number 6. That's 7 bytes in total. And the different bits for each byte read give us different bits of data. So for example, in address 0, bits 0 to 3 represent the seconds, and bits 4 through to 6 represent the tens of seconds. And on the right hand side you can see the range of data we might expect back. So within all of these 7 bytes we actually have all the information from the current second, minute, hour, the day of the week and the date. So going back to our code, we've now read the 7 bytes and stored that in a buffer. And then as we go through the buffer, 1 byte at a time, we're going to store those in some local variables. And after that, we'll then step through each one of those one at a time and call our debug routine to print it to the screen. And so you can see it's fairly easy to read information from the module for basic things such as the date and time. Now one thing you might be asking is how do we actually set the time correct on the module? Well, this is where this bit of code comes in. Set time binary. I'm not going to go through the code now, but I have provided the sources on the GitHub. This small application is a MOSlet and needs to be stored in your MOS directory. It can then be executed at any time. If we try to run the program, you'll see what happens. It's expecting a number of arguments, and it's telling us here what those arguments need to be. So we use the command set time followed by seconds, minutes, hours, day, date, month and year. So for example, set time 0 seconds, 13 minutes, 11 hours, the 5th day of the week. The date is the 25th of the 10th month of 2024. And it's now set the module to that time. If we run our clock program, you can see it's used those settings that we've just set. MOSlet RTC is another MOSlet. I've written this as a MOSlet so it can be run automatically each time you boot your Agon. If you look at my Agon autoexec.txt file, you can see that the third item is mos_set RTC. So this gets run automatically at boot time and sets the Agon's clock to what's stored on the module. So if you need your Agon to keep track of the actual date and time, then this module could be useful.